Welcome back to Hoochos. Today on Hoochos, we'll be unboxing, reviewing, and par testing this. This is the LiteOnGrow MF6 800W Foldable Grow Light. Let's get to unboxing. Okay, so straight up, non-discreet packaging. So, manual, a hefty power cord with an Australian fitting. How good. Okay, so there's that power cord. We've got hangers, looks like proprietary wires for hanging. And this will be a daisy chain cord, so it's daisy chainable apparently. Take it out. Protection for the dimmer knob. Really compact. Oh, this is pretty cool. And here's the fold. Oh, look at that. Oh, that's cool. That is a really nice footprint. Oh, it's gonna be really hard to film too. Okay, so let's talk a little bit about the design of the light and then we'll get into the specs. The light is designed essentially to be shipped cheaply and also to be hung more effectively, as we'll see a bit later. The design includes 4 elbows which turn 90 degrees and 4 elbows which turn 180 degrees. So the light can be manipulated around the plants if you were to grow in, say, a line. So this would give really good canopy penetration. For the fact that it's spread over a large area will give canopy penetration either way. So this is a champion of the multi-point lighting strategy, where you're lighting the plants from multiple points above the canopy. This allows the light to reach through the canopy and to the lower leaves, allowing the plant to absorb as much of the light as possible. The light is hung from 2 main hangers on the back, and it is also supported by proprietary fixings which stabilize the light once it's hung. Okay, so the tech specs. It's an 800W grow light and it's powered by a SOSEN driver, which is hidden internally within the spine of the light. This is the same driver that the original Mars Hydro lights used, and it worked perfectly fine in those lights. The driver is powering an array of Epistar diodes. So it's a full spectrum light with 660 nanometer red diodes spread out across the PCB. The PCB is passively cooled with the heat radiating through a thermal paste and into these anodized aluminium heat sinks on the back. The surfaces of the diode are covered with a water resistant coating, and this light is rated to be used within a grow room environment, i.e. damp conditions. The light can be dimmed in increments of 25%, so off 25%, 50%, 75%, and 100%. Having such a large footprint, this light actually has a really large flower and veg area as well. So for veg, you're looking at a 6x6 area, and for flower, you're looking at a 5x5 foot area. And the claimed efficacy is 2.7 micromoles. So let's hang this light up, put a par sensor under it, and see how it goes. So I'm going to show you what I mean when I say that hanging's a bit easier. Just because you can kind of rest the light down and then set up your hangers from there, rather than have this massive thing flailing around underneath. So the way that we hang it is we get our hangers and put it in like that. That will support the outer arm and that will support the other outer arm, but we don't need to put those outer arms up until we've hung it. And then we can flip out our arms and they'll just clip onto there. Well, I like that. That was easy. I was a little bit worried about like how well it'd be supported, but it seems to be fine. Now, these elbows have no resistance in them. And you can tell that these ones do because obviously these arms aren't just flapping around. So these can actually extend fully out like so, or you can have them like aimed down at the canopy, which I like. I really like that. So if you're just doing, you know, a line of plants, or even if you're doing a square of plants, you can face it in so that it shoots the light down at the canopy, whichever way that you prefer. Yeah, I actually do like that. Very cool. Okay, so I've got a couple of issues with the testing of this light. Now, the first issue is it won't fit in my reflective test area that I introduced last light review. So I'm gonna have to do it in a non-reflective test area. So this PAR and efficacy is going to be lower than it would be in a reflective area. And you need to take that into account because light companies almost always test their lights in a reflective area. In fact, they'd be silly not to because it's kind of the expected. So the efficacy for this light's probably going to be a bit lower than the quoted efficacy. Now, the second problem I'm going to have is the suggested hanging distance. Now, I understand that this is a professional grow light and it's meant to be hung in arrays, which actually makes sense not to test it with reflective walls because what array of lights has reflective walls? However, the hanging distance for vegetative is 48 inches. Now, just for perspective, 48 inches is going to go off the top of the screen probably. 48 inches is 4 foot, which is, I mean, it's taller than the ladder. So that's your vegetative height. And your flowering height is 30 to 36 inches. So still, that's 3 foot. So that is actually, well, that's actually the height of, just under the height of the ladder. I'm not sure that that's going to be correct. So what I'm going to do is, I'm going to turn it up. It's up to 100 right now. I'm going to get the appropriate PPF reading in the center of the light, and then I'm going to work backwards from there. So, right dead center, we're getting a PPFD reading, 1236. Now that's way too high, obviously. Probably my ideal would be anywhere from 750 to 1,000 in the middle. So we're gonna raise it until we get that. All right, I know plants can handle that. Let's measure the height there. Now that's almost at the stage of CO2 enrichment, but they can still handle it. So 15 inches. Now, that's probably about right. If you wanted to reduce the amount of light that's hitting the plants, you'd just turn it down. Like, why would you hang it any higher? Because you're just gonna hit the inverse square law. My recommendation would be 15 inches above the canopy, which is 38 centimeters. And the test area will be, this is a 1x1 area. So if I add an extra segment on each side, I'll get 140, just under a 5x5. So 140 by 140, 1400 by 1400 area. Let's get to measuring par. I'll set up some quick heat tests. So we'll put some tape on the back of the driver, although there's no heat at all coming from that. We'll put some tape on the lights. So I think this one's the hottest I can find. On the driver case, it's nothing. 27.5 degrees Celsius, which is 81.5 degrees Fahrenheit. On the LED heat sinks, 31 degrees Celsius and 88 degrees Fahrenheit. All right, so the hottest part I could find is 40 degrees Celsius, which is 104 degrees Fahrenheit. And even then, like, I can comfortably keep my hand on it. Okay. Very good. I mean, some of them are just so cool though. And the watt draw from the wall is 792. Okay, so I've got the figures and I've done all the maths, and I'm gonna put the PAR map up here, and let's discuss the PAR map before we get to the efficacy, because I think the PAR map is more important for these larger fixtures. Now, as you can see in the PAR map, we've got a really nice spread of PAR. Even in the dead center, that's not where the hot spot is, it's out to the sides, because the two bars that are in the center are wider apart than the bars within this central area. So it's actually spreading the PAR out really nicely, and we've got really high PAR across the board. Now on the outsides, we've got about an average of like 500, so it's between 824 and the lowest being 323. So you're looking at about an average of about, 500-600. Now that's really good, because if you were having fixtures next to it, you expect to double that average up to about 1,000 to 1,100. So it's got a really even light distribution. Now the light's 800 watts, and the average across the whole area was 813 for PAR. Now, obviously that would go up if you had reflective borders, but you wouldn't really be looking at reflective borders with this light, because it would be hung in an array where the lights next to it would push up the PAR. We'll times that by the area, which is a 1.4 by 1.4, which is just under a 5 by 5, and we get 1,138.2. We then divide that by the watt draw, which is 792, and we get an efficacy of 1.4. Now that's not a really impressive efficacy. However, this light would push that efficacy way up if you had reflective borders, and hung in an array, you would be utilizing all of the light outside of those borders anyway, because you'd have plants next to it which would catch the excess light. So I think this light's efficacy, if you were to have it in those areas, would be much higher. You'd be looking at like 1.9 to 2.0. Now the stated efficacy is 2.7, but that is probably of the diodes, which are the Epistar diodes being run by that SOSEN driver. So decent quality components throughout, really good build quality, nice design, and I actually think it's a really nice light, especially since you're getting 800 watts of light and it's getting a really nice coverage across the board. My hanging height would be probably that 14-inch height. You could push it up to probably 15 or 16, but realistically, if you wanted less light on the plants, you would just dim the light. All right, well, I hope you enjoyed this episode of Hoochos, and I'll see you next time. Happy hydroponicking.